Hello friends, in this session we will be discussing about one of the most important topic of digital electronics, Karna maps, also known as K-maps. This is the most important topic because most of the circuits are designed using the K-maps. K-maps, this is a pictorial method which, like a truth table, is a means of showing the relationship between input and output for a variable. But unlike truth table, it also helps in minimization of the Boolean expressions. We are having a truth table. In this truth table, we are having two inputs and one output, and the relation between the input and the corresponding output is also shown here. For example, for the input 0, 0, we are having the output A. For the input 1, 0, we are having the output C. The same information we can get from the Karna map. These are the two inputs which are mentioned outside the boxes, and the value inside the box is the output. Here, when A is 0, B is 0, the output is A. When A is 1, B is 0, the output is C. It means we can get the same information as that of the truth table from the Karna map for one variable only. The various advantages of K-map are: K-map method provides a simple and straightforward method of minimizing Boolean expressions. No need to remember all the laws and the theorems of Boolean algebra. It is more orderly process with well-defined steps than the Boolean algebra. With the K-map, Boolean expressions having up to 4 and even 6 variables can be simplified easily. After that, this method becomes a bit complex. How to draw a K-map? We are having a truth table, and from this truth table we just want to draw a K-map. We are having three inputs A, B and C and one output Y. Draw a square box for each entry in the truth table. Total number of square boxes or cells are equal to 2 raised to power n, where n is total number of input variables. Here we are having 3 variables, so total number of boxes will be 8. 2 raised to power 3 is equal to 8. Define variables to the cells or boxes. The care must be taken while defining the variables. The adjacent cells or square boxes in each direction, horizontal or vertical, differ by one variable only. This is very important. Differ by one variable only. Because the K-map follows the principle of A plus A bar is equal to 1. This will be possible only if the adjacent cells have the difference of one variable only. We'll see how. These are the 8 square boxes. This is how we have to define the variables to each and every box. We are having a variable here. We are having variable BC. We can take also AB together and C separate. Now we have defined A bar. Here we have defined A. While here it is B bar, C bar, B bar C, BC, BC bar. If you will see, this particular box will be known as A bar, B bar, C bar. This particular box will be known as A bar, B bar, C. This one A bar, B, C. Now if you will see, the adjacent boxes, they are differing only with one variable. In these two boxes, this variable is changing, C bar and C. The rest of the two variables remain same if we are going horizontally. If we are going vertically, again here this box represents A, B bar, C bar. Again, the difference of one variable only. The same thing can be represented in this way. As we know, 0 represents the complement of a variable. Here we are having the variable B and C. It means it comes out to be B complement, C complement, B complement, C, BC and BC complement. Here 0 represents A complement and 1 represents A. The two tables give us the same information. Fill the values of the output in the corresponding cells. This is the truth table which we want to replicate in the K-map. Here the values, output values are filled inside the boxes. 0, 0, 0, output is 0, 0, 0, 0, the output is 0 here. When A is 0, B is 1 and C is 1, the output is 1. When A is 0, B is 1, C is 1, the output is 1. When A is 1, B is 1, C is 1, the output is 1. The output is 1. When A is 1, B is 1 and C is 0, the output is 0. A is 1, B is 1, C is 0, the output is 0. In this way, we have to fill all the values of the truth table into the boxes of the K-map. Now the second part of the K-map is the simplification of the Boolean expressions. Here we have to perform two steps. The number one is grouping. The number two is minimization of expressions. Rules for grouping sum of product forms. As we know that there are two types of forms. One is sum of product and second is product of sum. Here we will focus our attention to sum of product only. In SOP, we group the adjacent group of ones. The various rules for grouping are: the group may not include any cell containing a 0. We are having this K-map. We cannot group like this one. This is wrong. We have to group only the number of ones. Again, I am repeating, in sum of product. The groups may be horizontal or vertical but not diagonal. The groups may be like this one, but it should not be like this one, the diagonal one. The groups must contain 2 raised to power n cells. Means a group may contain 1, 2 number of ones, 4 number of ones, 8 number of ones. But it should not contain. Here number of ones are 3. We cannot have this group. Each and every one must be grouped. If any particular one cannot be grouped with the other ones, it can form its own group. Here in this case, this one cannot be clubbed with the other ones, so it can form its own group. Groups may overlap. Here we are having a group of 4 ones. Now another group can also take the values from this group. Now here in this case, the second group is formed by taking the 2 values or 2 number of ones from the previous group. This is possible. Each group should be as large as possible. Here we have taken one group. Here we have made a group of 2 ones, but the possibility here is to make a group of 4 ones. So we cannot make this group. This is wrong. We have to make a group having 4 number of ones, which in this particular case. Groups may wrap around the table. The leftmost cell in the row may be grouped with the rightmost cell, and top cell in the column may be grouped with the bottom cell. Here we are having a K-map. Now this and this one, they can be grouped. Why? Because there is a difference of one variable only. If you will see here and here, the difference of one variable is there. If there is a difference of one variable, those particular ones can be grouped. Now in this case, this can be one group, this can be one group, but we have to make the maximum group, so the whole can be grouped this way. This is not right. This is not right. And we will have this group. There should be as few groups as possible, as long as this does not contradict any of the previous rules. We cannot group in this way. This is wrong. We have to make the group of maximum number of ones. And again I am repeating, the groups must be of 1, 2, 4, 8 number of ones. The second part is minimization of expressions. A group of 2 cells is known as pair. From a pair, variables will get eliminated, which changes from complement to uncomplement and vice versa. We will take an example. Here we are having one K-map. This is one group. This is the another group. Now from the first group, one variable will get eliminated. Which variable? Which will change its form from uncomplement to complement. The output for this group will be A bar B. How it comes? We will see. This group represents, or this one represents A bar B C, and this one represents A bar B C bar. From this we can take A bar common, B C plus C bar. From the rules of Boolean algebra, C plus C bar is 1, so it comes out to be A bar B. From the second group, A is changing from 0 to 1, while there is no change in the value of B and C, so the output will be BC. The overall output of this K-map will be bi is equal to A bar B plus BC. A group of 4 ones in the adjacent cells is known as quadrant. From a quadrant, two variables will get eliminated, which changes its form from complement to uncomplement and vice versa. Again, we are having a K-map. In this K-map, we have formed one group. From this group, the output will be two variables will get eliminated from A, B and C. Which variable? Those variables, those will change. Here B and C, they are changing. So these two will get eliminated then, and the output for this group will be A bar. While the output for the other group will be here, if you will see this group, the second group, in this group, the value of B is not changing from, while the value of C is changing from 1 to 0, 1 to 0, and the value of A is again changing 0 to 1. So the output will be B, and the overall output of the K-map will be A bar plus B. A group of 8 ones in the adjacent cells is known as octet. From a octet, 3 variables will get eliminated, which changes its form from complement to uncomplement and vice versa. Octet means 2 raised to power 3, and 3 variables will get eliminated. Here we are having one octet. The variables which changes its form from 0 to 1, and AB is changing from 0 0 to 0 1 to 1 1 1 to 1 0. All these will get eliminated. The output for this one will be D is not changing. The output will be D. Similarly, from a group of 16 ones in the adjacent cell, 4 variables will get eliminated. Don't care conditions. Don't care conditions, also known as cannot happen conditions, the conditions which cannot happen, is a situation that sometimes occurs when certain combination of variables of a function cannot occur. For these combinations, we can select the value of the function to be 0 or 1, whichever leads to the more minimal solution. I am again repeating, whichever leads to the more minimal solution. For these cannot happen and do not care situations, the Karna map entry is cross or X, indicating that the particular cell can be taken either as 0 or 1, whichever leads to the more minimal solution. We'll take an example. Here we are having one output Z, which is a function of A, B, C and D. These are in the SOP form and here represents its decimal equivalent. With the don't cares, these are the don't care values. We have formed one K-map as we have discussed earlier. Now we have to group. Now we are having one here, one here, one here, one here and one here. Each and every one must be in one of the groups. If I want to make the group of 4, I can take these two ones as 1 1. But if I will take the group of these 8 by taking this as 1, this as 1, this as 1, this as 1, because we have to form the largest group as possible, because with the larger group we will have the minimal expression. Similarly, these 4 can be combined to form a group X. Since I do not require this X, so it will be 0. This will be 0 and the output will be D for the group 1, and for group 2 the output will be BC. In this way we can use the don't care conditions to the benefit of the circuit. In some books it is mentioned that we can directly fill the values. These are the decimal values which are shown over here of each cell. While filling the values directly with this method, please keep in mind that this is MSB, A is MSB and D is LSB, and the value of these they are fixed. If we will change these values 0 0 0 1 1 1, if I will make it 0 1 0 0, then this becomes wrong. So if you want to use the min values based upon the decimal values, then you have to fix the outer part of the K-map with A as MSB and D as LSB. Five variable K-maps. In 5 variable K-maps, we consider 2 4 variable maps superimposed on one another. Let we have a function having 5 variables A, B, C, D, E, where A is the MSB and E is the LSB. Then we can make two maps by keeping A is 0 and A is 1 as this is one map, this is the second map. The two maps They are having the variables B, C, D, E, but this particular map is having the value of A0, and this particular cell will be having the value of A bar, B bar, C bar, D and E. While this particular cell will be having the value of A, B bar, C bar, D, E bar. Grouping we can do the same way. There is only one change, that corresponding boxes, for example these two boxes, now can be combined. There is a difference of one variable only. If there is a difference of one variable, then those two boxes can be combined or grouped. That's all for today's discussion on K-maps. And the references for today's discussion are Fundamentals of Digital Circuit by A. Anand Kumar and Modern Digital Electronics by R.P. Jain. Thanking you.